So a thin double convex lens of focal length f is broken into two equal halves at the axis. The two halves are combined as shown in figure. So this is the original length given here. This lens is broken into two halves. Once it is kept this manner and then in this manner. The question is, what will be the focal length of the combination in two cases, I mean case 2 and case 3. Obviously, we will be using the combined focal length formula 1 by f equal to 1 by f1 plus 1 by f2. Now, what is the focal length when it is cut into two halves in this manner? For first half, if the focal length of this part is taken as f, this one is also f. But now they behave this manner or in this manner. This manner means one part, the first part is obviously converging one, but this one is diverging one. Because lens is made of prisms. Many prisms are there. It will bend. The first case, a prism, a small part of the lens, a prism, will bend a ray towards the base. In the second case, a small part which can be considered as prism, it will bend the ray away. So, if a ray enters here in the first case, after refraction it will bend towards, and when there is a scope of coming out a ray from the second one, then it will bend away. So, in this case, it will be converging one. Although both are converging, but if you keep this manner, it will behave like diverging one. So, in the first case, 1 by f is 1 by f plus 1 by minus f, 0. So, f is going to be infinity in the first case. What happened in the second case? Two lenses both are converging here. Both the parts are converging. So it means focal length of each part is going to be f only. Focal length doesn't change if you divide this manner. So new focal length be f dash. Original focal length for this one is f. For this one is f. So 1 by f dash will be 1 by f plus 1 by f, 2 by f. So f dash going to be f by 2. Okay. The focal length going to be f by 2 in this case. F by 2. In the second problem, I have the effort to remind you the power of length. Power is 1 by focal length expressed in meter. Okay. Power of a length is 1 by focal length expressed in meter. And normally it is unit of power is in diopter. We express with this symbol D. So if we have combined focal length 1 by f equal to 1 by f1 plus 1 by f2 and assume all are expressed in meter, then power in the first case will be P1 plus P2. Okay. P will be equal to P1 plus P2. Now, just by looking this part, power of the lens, we can decide whether it is converging or diverging the lens, because for a converging lens, focal length is always positive, and for diverging one, f is negative. Okay. So if you consider power of this combination, that power will be equal to P1 plus P2, 6 minus 2, 4. It will behave like a converging lens. Okay, because power is greater than 0. If it is greater than 0, it must be a converging one. So this one will behave like converging one. Now let us go for this one. Equiconvex length of focal length f is cut into two identical plane convex lenses. How will the power of each part be related to the focal length of the original lens? Not a difficult one. All of you can answer. Equivalence lengths of focal length f cut into two identical halves, identical plane convex lenses. It is equiconvex. It's a plane convex lens, means one side will be plane here. This is the lens. If you cut by this plane here, then this is one and this is the other one. So this is like Plano-convex lens. What will be focal length of each part? This is not a difficult one. Here, radius of curvature you first assume equiconvex, no? Let R be the radius of curvature. Then 1 by f will be equal to mu minus 1 by r, because this r is positive and this is negative. So minus 1 by minus r. This is going to be mu minus 1 2 by r. So f is equal to r by 2 into mu minus 1. Now, for each part here, which we get after dividing in two halves, let the focal length be f dashed. So 1 by f dashed will be what? Mu minus 1. This part is plane. So radius of curvature is infinity. Minus 1 by minus r. So 1 by f dashed is going to be 0 and this is 1 by r. So f dashed is what? R by mu minus 1. But this is twice of this thing. So f dashed is 2 into r by 2 into mu minus 1. This is 2f. Clear? So focal length of this plano-convex lens or this one, both of them have the same focal length, which is given by f dash, and f dash is equal to 2f here. Power will be changed accordingly. In the first case, power is what? 1 by f. Assume every data is in terms of meter. So it will be 2 into mu minus 1 by r. What is the power in this case? P dash. This will be 1 by f dash. This is nothing but for this one. 1 by f dash is mu minus 1 by r, P dash. So this one is half of P. See, focal length becomes double, but power becomes half. Why? Because the power and focal length, they are inversely related. Okay? So P dash becomes half P, whereas focal length will be equal to 2f. Go for this one. Double convex lens is made of glass of refractive index with both of equal radius of curvature. Find the value of its radius of curvature. This is not a difficult one. You will be able to do. Only power is involved. That's why I want to do one sum with you. Power is given 5 diopter. So P is 1 by f. F is in meter. So F is in meter will be 1 by P. 1 by 5 meter. This is 20 centimeter. Focal length is 20 centimeter. Refractive index they have given 1.55. So use lens maker's formula 1 by f mu minus 1 by r1. This is double convex, equiconvex. So radius of curvature for one part positive, for the other part it is going to be negative. So this will be 1.55 minus 1 2 by r. This is 0.55 into 2. The value of r we don't know, but we know the value of f. So 1 by 20 is equal to 1.1 by r. So r will be what? 20 into 1.1. This is 22 centimeter. Clear? Hope you have understood. There is no problem in it. Let us go for the next problem. A convex lens of focal length 25 centimeter placed coaxially in contact of a concave lens of focal length 20 centimeter. Determine the power. So concave lens and convex lens. One has focal length f1 plus 25 and f2 minus 20. Okay. So this is nothing but 0.25 meter and this is 0.20 meter. Now power is what? P1 is 1 by f1, 1 by 0.25, 1 by f2 minus 1 by 0.20. Okay. So power of combined lengths will be what? P equal to P1 plus P2. So this is 1 by 0.25 minus 1 by 0.20. 100 by 25, 100 by 20, 4 minus 5, this is minus 1 diopter. So power has become negative, so it will behave like, it behaves like a diverging lens. Alright, hope you have understood. These are not very difficult sums. Now we go for lens combination, lens mirror combination. Before I start this one, I'd like to tell you, for lens combination, never forget to use the lens formula correctly, and this common information that focal length of convex lens is positive, focal length of concave lens is always negative. In case of convex mirror, focal length is positive along the direction of light, it will be. In case of concave, it will be negative. And we will be using the mirror formula over there. That is 1 by V plus 1 by U equal to 1 by M. Let's see what kind of problem arises here. Go to the next one, which is a convex lens of focal length 20 cm placed coaxially with concave mirror of focal length 10 cm at a distance 50 cm apart. A beam of light coming parallel to the principal axis is incident on the convex lens. Find the position of final image formed by the combination. Draw the ray diagram showing the formation of image. This is actual lens mirror combination problem. So what you need to do here, you always have to do a proper ray diagram. In the beginning, if you are not able to do, you just do a rough sketch and then proceed. Okay? So here convex lens is given first. And then there is a concave mirror. This is the concave mirror here. Okay. Now convex lens focal length is given 20 cm. This one's focal length is 10 cm. And the distance between these two is 50 cm. Beam of parallel light, common principal axis. You take the beam of parallel light, entering this manner. Parallel to the principal axis, incident on the convex lens. Find the position of final image formed by the combination. So this is a converging lens. It must meet at the focus of the lens. Means they will meet at a distance 20 cm. This is converging one. This is converging one. They meet at this point, which is focal length of the first one. take this one as the image. Now this is given what? This one 20. So this part is going to be 30 centimeter. So this ray continue its path, the middle one. This one will go this manner. This one also will go. This one continue its path, no? It will follow the same straight line path. Now, you have to get a proper ray diagram over there. The focal length here 10 centimeter. So center of curvature in this one 10. Center of curvature will be at a distance 20 centimeter from here. Accordingly, we are going to draw the normal here. The normal will be like this. This is C in 1. And for this one, normal is like this. This is normal. So I did not put any direction of arrow over there. Okay? No direction of arrow will be there. Just a minute. It's okay. Now, this is the direction of normal N2. After this, it will bend away from the normal or towards. This will follow the law of reflection, no? So, reflected light should come this manner. By obeying the law of reflection, I equal to R. Here also I equal to R. This is the ray diagram. Okay. So final position of image will be here. And is it supported by the mirror equation? This will be supported by the mirror equation. Here, image is formed at the focus. Now, this image is I dashed. This image. This image is the object. I mean, behaves like object. Object for the mirror. So, for the mirror, U going to be what? For the mirror, for this mirror, U is minus 30 because this part is 20, this will be minus 30. For each F over there, F is negative, that is minus 10. So 1 by V, this is 1 by V plus 1 by U. So plus 1 by equal to 1 by minus 10. So 1 by V will be what? 1 by 30 minus 1 by 10. 30 is the LCM. This part is 1 minus 3. So this is minus 2 by 30. Therefore, V will be what? Minus 15 centimeter. So this arrow diagram is supported by the equation also. The final image is formed. The final image I is formed at a distance 15 centimeter left of the mirror. It is 15 centimeter left of the mirror. And I think I have done the proper diagram for you. Okay. So for this problem, diagram is like this. Object is here and this is the image. Mirror, this is lens. Since it is given, the image is formed at the position of the object. So one ray will be going there and then send a ray parallel. It will meet here. The point A will be coming at A dash. And this is B dash. So image is A dash B dash of AB. Now the ray has to come back to the same object here to get the position of the image. Now check whether this diagram will be supported by numerical calculation or not. Object position is 15 centimeter and focal length is 10 centimeter. This is the position of image V or V1. So for the lens, 1 by V minus 1 by U equal to 1 by N. 1 by V1 minus 1 by minus 15 equal to 1 by 10. So this is 1 by 10 minus 1 by 2, that is 30, 3 minus 2. So V1 is 20. No, not 20, 30 centimeter. So this one 30 centimeter. Distance between this and this, you have to find this distance now, x. How to find it? For the concave mirror, the image and object must coincide. So it must be situated at the radius of curvature. As the object and image coincide, as the object and image coincide, the value of the position of object will be where? Must be at C, the center of curvature. So if this is the center of curvature, this distance going to be equal to 20 centimeter. Okay. So the mirror has to be placed at what distance away from the lens? This part 20. Therefore, distance between the lens and the mirror will be 30 centimeter plus, that is 50 centimeter. Clear? Hope you have understood. So this is the position of object. Finally, image will be formed here. First image is formed here, but due to the reflection from the mirror, these rays will pass through the lens and will meet the object again. So the distance between lens and mirror will be 50 centimeter. Now this one. You are given 3 lenses L1, L2, L3, each of focal length 10. An object is kept 15 centimeter in front of L1. The final real image is formed at the focus of L3. It is given at 10 centimeter. Find the separation between L1, L2 and L3. For this one, that focal length is 10 centimeter, object is kept at 15 centimeter. So for this lens, let us start first. Here, U equal to minus 15 and F equal to 10 plus obviously. So using lens formula for L1. For L1, let us use the lens formula. 1 by V minus 1 by U equal to 1 by F. You take this one, V1. So 1 by V1, 1 by 10 minus 1 by 15. 30 is the LCM, 3 minus 2. 1 by 30, therefore V1 equal to 30 centimeter. So the image is formed at a distance 30 centimeter away from the lens L1. Okay. Now we look at this information. Final image is formed at focus of L3. It means at 10 centimeter. So rays must enter parallel. Then only it can be formed at the focus. It means the incident ray after passing through L2 will be parallel. It means for L2, image will be formed at infinity. Okay, writing here, image is formed at focus because focal length is 10 centimeter. So it means rays after passing through L2 becomes parallel. Okay? And this is possible. This is possible when the object for L2 was at the focus. Am I correct? So object will be the first principal focus of L2. What is that? 10 centimeter. Okay? It is 10 centimeter. And this one we just found 30 centimeter. Clear? So distance between L1 and L2 is 30 centimeter plus this is 40 centimeter. Alright? Hope you have understood. Distance between L1 and L2 we can see. Distance between L2 and L3 that we can't see. Can't see means it may be any value, any real number. It is possible. Because rays are parallel, no? After passing through this, these rays are parallel. There will be incident this manner on L2 only, L3 only. These rays are parallel. So first you get the image here and then rays coming from here are incident in such a manner that they become parallel. So the position of distance between L2 and L3 may be anything. Clear? Distance between L2 and L3 is any real number. Okay? There is no problem in it. Distance between L2 and L3 will be any real number. For this problem, every information almost given except the focal length of the lens L2. Okay? We have to find L2, and you can see that the image is formed into L1 on the left hand side here, because A is going this way. If you produce backward, you will be getting the image over there, and that will behave like object for L2. So let us do it for L1 first. To find the position of image, we just write U1. U1 is what? Minus 15 centimeter. Focal length F1, always positive, convex. So if we write 1 by V1 minus 1 by U1 equal to this, therefore 1 by 20 minus 1 by 50. This is going to be 60. So V1 equal to 60 centimeters. Alright. V1 we got, wait a minute. Wait. 60, no, I have done some wrong calculation. This will be 3 minus 4. So this one is minus 60. This part minus 60. Which part? The distance of the image from the lens is minus 60, means it is formed on the left side of the mirror. Now for the object, for the lens L2, for L2, U1 is what? Minus 80 centimeter. Okay? And V1 is what? That is also 80 centimeter. So 1 by V1, for L2 we are going to use minus 1 by U1 equal to 1 by F2. This V1 is plus, this U1 is minus, therefore 1 by F2, 2 by 80, F2 is 40 centimeter. This is the focal length of the second lens. So convex lens is in contact with the plane mirror. Plane mirror, and there must be a convex lens in contact with this. Okay, and we take this is the principal axis of the lens, and it is given object distance is 20 centimeter. This is 20 centimeter. Object and image, they are coinciding. What is the focal length of the convex lens? The thing is that the path of the light ray, from the lens will be in such a manner that when it incident on the mirror, it must be perpendicular, because then only it can retrace. From the plane mirror, after reflection, the light must retrace its own path to form image at the position of the object. It has to meet. So if we send a ray this manner, the light ray after reflection must fall perpendicularly. This must be 90 degrees. If we keep a bit separation, it will be easier for you to understand. To form the object and image at the same place, this is the ray. It must fall on the mirror at right angle, this ray, so that it can retrace its own path and object and image will be formed at the same place. So this can happen. The rays, these are parallel rays. Parallel rays, parallel to principal axis. Possible when the object is at the focus of the lens. Okay, so focal length will be what? Because this is 20 centimeter, focal length of the lens is also 20 centimeter. Alright? This convex lens and convex mirror, both are convex, are placed coaxially with the convex mirror placed at a distance 30 centimeter from the lens. For a point object at a distance of 20 centimeter from the lens, the final image due to this combination coincides with the object itself. What is the focal length of the lens? Focal length of lens only not given, everything else is given. Okay? So the object and image coinciding means path has to be retraced. This one formed at 20 centimeter, this will behave like the first object is here. Object is situated on the left side here. Ray of light going, incident, refracted, then reflected, it has to retrace its path. So if it retraces the path, it is possible that it was directed along the normal. This is going to be the normal. Okay? If this is normal, this has to be the center of curvature for the mirror. That's why the distance is 20 centimeters. Okay, it is given, everything is given. Now for the lens, U is minus 25. Image was supposed to form at, for the lens, image was supposed to form at the point O dash. Image was supposed to form at O dash. Okay? If it is supposed to form at O dash, then V should be, here is that 20, but for the lens, V should be what? 30 plus 20. Okay? That is 50 centimeter. Now 1 by V minus 1 by U for the lens. 1 by V minus 1 by U equal to 1 by F. Therefore, 1 by 50 minus 1 by, so 1 by F equal to 1 by 50 plus 1 by 25. 50, 1 plus 2. So this will be 50 by 3. 50 by 3 is approximately 6.67. So length of focal length 20 centimeter given. Concave mirror of focal length and the distance between these two is 50 centimeter given. Beam of light, I have tried to draw the diagram. Beam of light parallel to the principal axis incident on the lens. They will be meeting at this point. So this is going to be the position of the image. Where do they meet? This distance has to be 20 centimeter. So for the mirror, this is obviously going to be 30 centimeter. Isn't it? It is formed at 20, so 50 minus 20, that must be equal to 30. Now, ray diagram is very important, and this is the center of curvature, normal drawn here. If you want to draw a perfect ray diagram, this is normal. After reflection, it will move away from normal or towards the normal, that we have to decide. If it goes this way, it has to follow the law of reflection. The center of curvature is at distance 20 centimeter. This part is 30. So center of curvature away from the point where it will converge. This ray will meet at a point like this. It will be the meeting point of this ray also. Okay. So final image is formed here. The position of that final image, this is I dashed, image formed by lens, and this is the final image I is formed. We can find this one easily. Clear? So for this mirror, U is minus 30 centimeter. F is what? F focal length they have given. This will be minus 10 centimeter. So 1 by V plus 1 by U equal to 1 by F. Therefore, 1 by V plus 1 by, therefore 1 by V equal to, so 30 is the LCM, 1 minus 3, therefore so V equal to minus 15 centimeters. So this distance image is formed, final image, this is final of course. Final image is formed 15 centimeter left of the mirror. Hope you have understood. It is formed 15 centimeter on the left side of the mirror. So lens of focal length 20 centimeter is placed coaxially with a convex mirror of radius of curvature 20 centimeter. The two are kept 15 centimeter from each other. The point object 60 centimeter in front of convex lens. Draw a ray diagram to show the formation of the image by the combination. Determine the nature and position of the image formed. So diagram almost like this. I have tried to draw my level best for you. This is the object which is 60 centimeter from the convex lens. Their separation is 15 centimeter lens and mirror. Focal length of lens 20 centimeter given, mirror 10 centimeter. For this point object, for the lens, one by V, 1 minus 1 by U. U will be what? Minus 60 equal to 1 by FL, that is 20. So 1 by V1 is, take the LCM here, then this is 3 minus 1. So 1 by V1, 2 by 60. This implies V1 equal to 30 centimeter. Since the separation 15, the first image formed by the lens is at I dash. For the lens, O is the object and I is the image. So image formed by the lens, I dashed, 15 centimeter from here. Now this is virtual, no? This mirror will not allow to converge the ray at the point I dashed. At least it will not appear to from I dashed. Instead, here there will be reflection. The reflected ray will be going just opposite manner. This way, by obeying the law of reflection. By producing it in forward direction, we get the final image. Okay? Similar is the case here also. After reflection, by following the law of reflection, it will go like this and then produce it in backward direction so that the final image is formed at I. So for the mirror, what do you get? U equal to what? From the mirror, the distance will be 15 centimeter and Fm equal to 10 centimeter. So 1 by V2 plus 1 by U on the other side of the mirror, Fm also on the other side. So 1 by 10. This implies 1 by V2, 1 by 10. So take the LCM. This will be 30 and this is 2 minus, no, this will be 3 minus 2. So V2 going to be 30. So in this case, the image is formed 30 centimeter away from the mirror. So final image I is formed at a distance 30 centimeter from the mirror. Hope you have understood. This is going to be a very interesting problem. I think it is linked with a problem in the textbook. Symmetric biconvex lens of radius of curvature are made of glass of refractive index 1.5, mu equal to 1.5, placed on a layer of liquid placed on the top of a plane mirror. This is the plane mirror. Optical needle with its tip on the principal axis. This is the needle, not pin. It's is moved along the axis until real inverted image coincides with the needle itself. The distance of the needle from the lens measured to be x. On removing the layer, liquid layer, and repeating the experiment, the distance is found to be y. We have removed the lens and then we observe that image and object coincide when the distance is y. This is going to be y now. Okay? This is the action of liquid lens. Because when you remove the glass lens, only liquid is left over there. Mirror's focal length is infinity. So equivalent focal length calculation, it has no role to play because 1 by Fm is 1 by infinity. This is going to be equal to 0. Let's go back to the problem now. So in the first case, what is known and what is unknown, let us see. I have taken this ray diagram here just to make you understand that how the pin and its image, the needle and its image coincide. Rays coming from the tip of the pin incident over there. Then I'll tell you it has to be incident on the mirror at right angle. Why? Because if it falls at right angle, then only it will retrace its path in backward direction to go back at the position of the object. For that, after passing through the lens, this ray will be, beam of rays will be parallel. Am I correct? Then only it is possible, no? But you know, when the object is placed at focus of convex lens, then only the rays become parallel. No other position it is possible. So it will be perpendicular, beam will be parallel to each other if the position of object at the focus. So this time the needle and its image will coincide if and only if this point or pin or needle is situated is the focus of the lens. Focus of which lens? So in the first case, in case 1, the situation arises only when the object, the needle, is at the focus. At the focus of the glass, liquid, the glass lens and liquid lens combination. Because I told you mirror has no role to play. So this X going to be focal length of the glass and the liquid lens. So 1 by X is going to be 1 by Fg plus 1 by Fl. Clear? Now, on removing the liquid layer, once you are removing the liquid layer also, not only the lens is removed, this is when lens is removed, there may be only lens only. Only lens is there. That also can happen. If only lens is there, then this will happen when the distance is, see, distance is y. Okay. So y is not the distance in this case. This you take better for this manner, just to imagine the liquid lens. Liquid lens is of what form? Liquid lens is plano-convex lens, because this side is plane and this is concave. Plano-concave. And this will help you to understand the value of FL. What is Fg over there? Because when liquid is removed, the distance becomes y, where the pin, the needle and its image coincide. So obviously going to be the focal length of the glass lens, that is Fg equal to y. Clear? Fg equal to y, but Fg is what? 1 by Fg equal to mu g minus 1 by r minus 1 by minus r, because it is a glass lens and equiconvex lens. My diagram is not very clear, but imagine this is a equiconvex lens. This is 1.5 minus 1 and 1 by r, 1 by r, 2 by r. So 2 into 0.51 by r. So Fg going to be what? Fg or y is equal to r. In this case also, the situation will arise if it is placed at the focus, and ray after passing through the lens becomes perpendicular. Then only it will retrace its path. Got the point? So Fg equal to y equal to r. Now what is FL? FL is the combination of this liquid lens and the glass lens. Okay? Combination of the liquid lens and the glass lens. How do I account for that? Just let us go by this diagram. We can say that 1 by FL equal to, just go by this diagram, 1 by FL equal to mu minus 1, that is mu liquid minus 1 by r So not 1 by r, Plano-convex. This is 1 by infinity. No, this one facing first. It will be 1 by r only. 1 by r minus 1 by infinity. And this is minus. Therefore, 1 by FL equal to 1 minus mu L divided by R. Now, take this relation into consideration, that is what? 1 by X is 1 by Fg plus 1 by FL. Okay. You got the value of FL. You got the value of Fg also. So, apply it there. Therefore, 1 by X equal to 1 by Y plus FL, 1 minus mu L by R. Alright. Therefore, 1 by X equal to 1 by Y, and this R is Y only. This is Y. This implies 1 by X equal to 2 by Y minus mu L by Y. Therefore, mu L by Y equal to 2 by Y minus 1 by X. So, mu L going to be what? 2x minus Y by X, if you multiply both sides by Y. Hope you have understood.